Okay. So, we got here last time. We're not doing the Merkle tree yet. We have to do the Merkle tree next week, I think. I think there's I want to formally teach you how I would implement the heap data structure. So this is crazy, right? So we implemented stacks on the heap. Then we're going to implement the heap on the stack, right? But I want to introduce some tree terms. Trees are connected. There is an edge from one node to every other node. What is the negation of this? So you can have, here's my tree, right? It's happy and well adjusted, right? Okay, it's still a tree, still a tree. Oh, it's over here, oh, it's over here. Oh, this node isn't connected. Well, this is not a tree, 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 not a tree. Tree. Ah! It's fine. Okay, ready? I'm going to do one more. Oh! Okay, trees are connected. This is a tree. I'm going to draw something. Tell me if it's a tree.
No.
How can I make it a tree?
Connected to something.
I can connect it to anything. Tree. Boom. Okay. I think we can stop now. That was probably done. Okay. Connectedness is usually defined over unconnected graphs. Why is that? Well, you might say, oh, nothing is connected to this because there's only an outgoing connection. That's fake. Don't listen to the haters. Root. What is the root? The root is the node which has a path to every other end. It is the ancestor of all nodes. So, okay, here's our tree, right? I'm going to label these in the order that I drew them. Wow, my handwriting is so good. It is so obvious what we're looking at here, right?
It would be more obvious if you did the head tracking thing.
I was like, yeah, I don't have any idea how to do that. Wait, oh no, it's not a tree. It's not a tree. Which way do we want to go? Let's go this way. Okay. Oh, wait, this is not a tree. Hold on. See how this one has two incoming edges? Folks, that's banned. Hit them with the delete. Boom, done. Treed. Okay. So, what is the root of this tree? Fun fact, it's underspecified because I didn't label this edge, right? So, either this is the root and this is a directed edge in this way, or it could have been the case that this was the root and there was a directed edge going the other way. So the root is the ancestor. A leaf is a node that has no outgoing edges. So let's take a look at some leaves. The Leaves are a sports team from Toronto? Yeah? What sport?
Hockey.
Okay, yeah. And to annoy the Canadians, you always say ice hockey. Right. Not that we're trying to annoy the Canadians. I think we're annoying the Canadians enough already. Okay. So, this folk is a leaf. This one's a leaf. This one's a leaf. This one's a leaf. This one's a leaf. And I know what you're thinking. You're thinking, when is that going to matter in real life, right? No one cares about leaves, Calvin. Okay, so see this class right here? CS262 web development. You see, we all see it. We're all gazing upon it, right? How this one over here? 352 linear algebra. Notice how these don't have any outgoing edges out of them? Notice how they're kind of leaves on the graph? Well, you'll never guess this, but in the CS major that we designed, the only places there are distributions where you can choose which class you take are in leaf nodes. That's how we decided you could do it. So, this here, this is a leaf node where you select software, web, mobile development, or an elective. So this term I think was game development. Why can that be a distribution? No class requires that class, so we can have a broader range of things we can possibly teach in it. And I know what you're thinking. You're thinking, that's crazy. That's a single motivated example. There's no way that's also true of linear algebra, right? No way that's true? Someone said, okay, I thought I heard one of my haters say that might be true. So, not to worry. I have all day for my haters. What is this? Oh, you can choose to take linear algebra, which has a Math 251W prerequisite, or you can also instead take complex variables, which has the same prerequisite. But these classes are not required by any later classes, so you get more choice in what you take. When do you not get a choice in what you take? I know you're all here voluntarily, right? Because free will exists, right? We had to make you take this one because someone has to teach you enough stuff that you can take operating systems with me next term. Now, do you have to take operating systems? No, this is a topics class, right? So I can teach operating systems or compilers. Rachel Brown down on the hall might teach graphics, right? So we might teach other things in that. So this, but you're thinking, I know what you're thinking. You're thinking, wait, that's not a leaf node. Okay, well, these ones are actually fake. This is the capstone. This just requires you to have taken a certain number of classes, right? So, okay, so we're straining the metaphor a little bit, okay, right? But, like, I was hanging out not too long ago. I cruised into Professor Jed Rembold's office, as I do every time I want to ruin his day. And I was like, what if we only put distributions on all the leaf nodes? And he understood what I was saying, which is crazy, because that was absolute nonsense. Okay, leaf. Diagram. Okay. 2 is the root. Can you see that at all? Actually, that's showing up okay, right? That's sort of okay? I was doing this thing in my last class where I put style at the end of everything, so that's okay style, right? It's visible style. Okay. So here's 2, it's the root. 2, 10, 5, 11, and 4 are leafes. I never know how to spell it. This is the parent-child relation. And so the way to think of this is, obviously, CS151 is the legal guardian of data 351. Anyways, I stopped using that terminology because it seemed weird. Height and depth. Height and depth are super useful. We can refer to the height and depth of a tree or a node. Okay, so what is this? The height and depth of a tree is the same. It is the length of the longest path. Did I teach you what paths are? No, but you know what a path is, right? It's just directed. So, what's the longest path in this thing? There's 2 of them. Math 150 to the capstone, and CS 151 to the capstone, and let's see their length. 1, 2, 3, 4, 5, 6. Right? Right? No way am I trying to trick you. Oh, no, you don't count the nodes on the path. You count the edges on the path. Okay, so it's actually 1, 2, 3, 4, 5, or, hear me out. I'm about to go index style. If you 0 index your counting of the nodes, then it works, right? So you can 1 index your counting of edges or 0 index your counting of nodes. Your minds don't seem as blown by that as I thought they would be. That's pretty cool, right? This is a natural occurring time where 0 and 1 indexing matters, and I'm applying it to actual real things, right? You can either apply it to classes or prerequisites. Okay. The height of a node is what the height of a subtree, which it is a root of, would be. Okay, so what is the height of let's hit Intro Physics 1. We're just going to check out Intro Physics 1, right? Okay, so Intro Physics 1 is over here, right? Is that what it's called? Okay, so we got Intro Physics 1, not a Roman numeral. Why is there not a Roman numeral? They didn't want us to have different character lengths of classes depending on whether it was the first or second in a sequence, so they asked us to use 1 and 2. This is a true story. I didn't know this. So we have Calculus 1 and Calculus 2 instead of Calculus I and Calculus II. I didn't know that. Okay, so we imagine we take this as if it's the root. Is this an image? Oh no, it's an SVG. Oh look, the edge has a new line character in it. Do you see that? Or the label? Okay, so how do I screenshot? Screenshot. No, that's not what I meant to do. I locked my screen. What's my password? It's password. Don't worry. Okay. I'm gonna collect my thoughts. I'm in shambles. I'm recovering. Okay, we're gonna get a screenshot. We're gonna get it on the first try. Okay. Boom. Nice. Okay, so we imagine we just take the subtree, so only the portion of the tree that would have intro physics 1 as the root. Then how do we calculate the height of intro physics 1 within the main graph? Well, it's whatever the height of this subtree is, which is 1, because there's this thing right here, right? So that means that the height of physics 221 is 1. Let's calculate the height of something else. Linear algebra, height of 0. Analysis of algorithms, height of 2. Data structures, height of 1, 2, 3, 4. Height of 4. There you go. Things have different heights. Okay? Cool. Completely locked in. Awesome. What is the depth? The depth of a node. Oh no, I thought I fixed these. I was so sure I fixed these. I'm so sad. What did I just press? I just closed the tab because I was tilted. Do I have recently closed tabs? Okay. Sweet. Okay. So the depth of a node is the height of the subtree of which it is the lowest leaf would be. And I think that makes perfect sense in English, but I'm going to show you what it looks. Okay. The node labeled 4 is of depth 2. Okay, so let's take a look at the depth of something. I think I'm going a little bit chaos style right now. That's okay. Okay. So what is the depth of human-computer interaction? Depth of 1. What is the depth of data 351? Depth of 1. What is the depth of CS 152 data structures? Depth of 1. Does that make any sense at all that those have 3 different 100 levels and all have the same depth? I didn't think so. No one asked me, right? Okay. CS 262 web development, what's its depth? 1, 2. Boom. Depth of 2. Okay. Easy. Size. That's how many things are in here. This thing's of size 16. Okay. Today, Dags, trees. Okay, graphs. Okay, a little bit more advising. Maybe you find this interesting, maybe you don't. Okay, is my brain working? Am I locked in? Okay. So, why is it? That's sad. Okay. That was for the new BSCS that we have now. So if you started attending this university before this year, you get to the choice of your BS computer science, since there's more than one. Here's the old one. Trying to tell if I'm on screen. Am I on screen?
Yes.
Okay. So we had CS 151. It had 2 branches. It went to CS 152 and Math 251. I'm putting them in boxes because it's easier on me. Okay. This thing went into, you have CS2, I'm doing 2XX. So this is like web app mobile development for the systems class that you're in right now, right? 2XX. And then also, these go into CS 351. And then, what is the other thing we have? We also had data 351. And then we also had data 352. Okay. So, oh, and then we have 2 electives. And the electives have no requirements. So, we have elective. Pretend that you can read my handwriting, okay? Right, so just imagine that you can read what's on the board, right? What is the height and or depth of this tree? Good question, right? It's 2. That seemed a little low for a 4-year degree because you're here for 8 semesters. Okay. So why did this potentially stress me out? I'm going to circle on here the classes that you cannot take at a community college. That's it. So this got me a little nervous, right? Now, when we put this degree together, what year was it? It was 2022. What was the unemployment rate for CS graduates in 2022? I don't know, but I think it was 0%, right? So like it didn't matter, right? What is it now? I think it's like 7.6%. Like that's way too high, right? I know. Okay, you don't believe me. I heard you not believing me. Okay, not to where I have a plan. Labor outcomes for new graduates. This thing haunts my nightmares, okay? Here's computer science, right? What's that? 6.1% unemployment. Okay, that's way better than 7.6. Okay, I had you all stressed out for no reason. Do not listen to me. 16.5% underemployment, but you make 80K a year on median. That's pretty good, right? Anyways, this thing was below 2% in 2012. The only things that are like below that now are civil engineering, nursing, making airplanes, health, right? So, anyways, I got stressed out by this, and I panicked, and now I'm going to make you all learn physics. So, okay, so by adding in systems computing, which now goes here, depth of 4, and then the capstone, we now have all of these classes that are not taught at a community college, and also our depth goes up to 5. Why is 5 good? Means you can start the major in your second year and go and study abroad. That's what it means. Okay. So, anyways, I got nervous about that. I like to make fun of physicists. They have 6. They're 6. They have 1 more than us. They're more powerful than we are, right? I meant to do that to demonstrate physics, right? So that was gravity, right? Okay. I can't bend over because my legs are tired. Oh my gosh. Okay. Ugh. The incline treadmill has ended me. Okay, so, does anyone want to ask any questions about advising or careers? Speak now or forever hold your peace. Okay, cool, good. Send me an email. I would like you to be gainfully employed someday if you want to